Strategy Management Series. Video number 108 Strategy Formulation. Step 7 Strategy Evaluation. Step-by-step guide to sequential games. Welcome back to the Ready MBA series on strategy management. In our previous sessions, we delved into strategy evaluation, the crucial seventh step of the strategy formulation process. This stage entails scrutinizing potential strategies for their impact, benefits, costs, and resource requirements. In our previous episode, we introduced the concept of game theory, a technique for predicting competitors' moves in a competitive situation, demonstrating how it can be leveraged by the planning team to refine their strategic analysis. One of the primary benefits of game theory is its ability to help decision-makers anticipate the potential outcomes of different strategies and understand the ripple effects of their choices. This is especially valuable during strategy formulation and evaluation, as it allows planners to simulate various scenarios and assess the best course of action. Game theory distinguishes between two types of games: sequential moves games and simultaneous moves games. Sequential moves games involve players taking turns, with each move visible to subsequent players. This allows each player to base their decision on the actions taken by previous players, providing an opportunity to adjust their strategy accordingly. Simultaneous moves games, on the other hand, involve players making decisions without knowing the moves of others. These games often require different analytical approaches due to the uncertainty of competitors' actions. In our last video, we also discussed some of the details of sequential moves games, explaining some key concepts such as backward reasoning, game trees, payoff estimations, and identification of the best strategy. In this video, we will present a step-by-step guide explaining how the planning team can identify and analyze sequential moves games. Creating a sequential moves and backward reasoning game theory analysis involves a systematic approach to map out strategic interactions, assign values, and determine optimal moves based on future outcomes. Here are the 9 steps to execute it. Step 1. Identify the game and the players. First, you need to identify the game that you are analyzing and the players involved. A game in this context refers to any situation where decisions made by players affect each other. For example, let's consider a game involving two companies, Company X and Company Y, in the technology sector, focusing on product launch strategies. The goal for each company is to maximize profits through the launch of a new product or sticking to their existing product line. Step 2. Define the sequential moves. Next, outline the sequence in which players make their moves. In a sequential moves game, each player acts in turn, with knowledge of the previous moves. Continuing with the product launch decision example, Company X moves first and decides whether to launch a new product, move 1, or keep the existing product line, move 2. Company Y observes Company X's move and then decides to launch the same type of product, move 1, or maintain its current product line, move 2. Step 3. Construct the game tree. A game tree visually represents the sequential moves and their outcomes. Begin by drawing a tree structure where each node represents a decision point, and each branch represents an outcome or choice. The initial node is the first move, Company X, with branches for possible decisions: launch or not launch a new product. The next set of nodes represents Company Y's decision, with branches indicating their choices based on what Company X did. Based on Company X's decision, Company Y can also choose to launch or not launch a new product. Step 4. Assign and estimate payoffs. For each outcome in the game tree, estimate the payoffs to be assigned to the corresponding branches. These payoffs can be financial or non-financial, depending on the context. To estimate payoffs, consider the potential revenue, costs, market share, or strategic benefits resulting from each outcome. The planning team may need to develop business models and financial projections to estimate the payoffs for each combination of strategic moves. In the new product launch example, the planning team estimated market potential, demand, potential revenues and related costs to launch a new product for both players. They developed a business model that forecasts profits for Company X and Company Y for each combination of strategies previously devised and described in the game tree. Payoffs for each of their moves are calculated based on market shares, revenues, and costs related to new product launch or not. The planning team estimates the payoffs for each one of the branches in the game tree. Branch number 1. If Company X launches a new product and Company Y does the same, they share the market equally. Company X gets 20 million in profits and Company Y also gets 20 million. Branch number 2. If Company X launches a new product but Company Y stays with its current offer, Company X profits will be 25 million, while Company B profits will be only 15 million. Branch number 3. If Company X stays with its current offer, but Company Y launches a new product, Company X will have 15 million in profits, versus 25 million for Company Y. Branch number 4. If both Company X and Company Y stick with their current offer and do not launch the new product, their profits will be 15 million each. Step 5. Determine probable outcomes. Consider the probable outcomes for each decision point. This might involve assessing the likelihood of each move and understanding the motivations and strategic goals of the players. By analyzing these probabilities, you can better understand the likely trajectory of the game. Collect competitive intelligence data and analyze historical data to validate payoff estimates, as well as the likelihood that competitors will pursue the identified strategic moves. Validate all assumptions as best as possible. If any strategic move seems unlikely, they can be removed from the game tree. This process helps to prune unnecessary branches and simplify the game tree. Step 6. Look ahead and reason backwards. This step involves determining the best strategy by reasoning backwards from the end of the game tree to the start. Starting from the terminal nodes, end outcomes, determine which moves result in the best payoffs and work backwards to identify the optimal strategy for each decision point. In the new product launch example, if the best outcome occurs when Company X launches the new product, then their best strategy would be to do so regardless of what Company Y decides to do. Company Y, in turn, must acknowledge Company X's first mover advantage and then plan their response in the light of such reality. If Company X will in fact launch the new product, Company Y is faced with the choice of launching a new product as well or sticking with the current product. Their decision in this case should be to also launch the new product, because this is the option that maximizes their payoff considering Company X's best strategy. Y gets a 20 million payoff instead of 15 million. In this game, the optimal strategy is then for both companies to launch the new product. Step 7. Evaluate strategic implications. With the optimal strategy identified, evaluate the broader strategic implications for the players. Consider how this strategy aligns with their overall goals and whether there are any risks or trade-offs involved. This evaluation helps ensure that the chosen strategy is robust and sustainable. Step 8. Test the strategy. Consider potential variations or uncertainties that might affect the strategy's effectiveness. Test the strategy against different scenarios to ensure its resilience in the face of changing conditions or unexpected moves by competitors. Step 9. Implement and monitor. Once the optimal strategy is identified, it can be implemented in practice. Continuous monitoring is crucial to ensure that the strategy remains effective as conditions change. This monitoring allows players to adjust their strategies as needed based on new information or evolving market dynamics. By following this step-by-step guide, you can conduct a comprehensive sequential moves and backward reasoning analysis, providing valuable insights for strategic decision-making and allowing for effective planning in competitive environments. And this concludes our episode about the step-by-step guide to analyze games with sequential moves and to identify its optimal strategy. Please join us in our next episode where we will continue our discussion about game theory and will introduce simultaneous moves games. Until then, keep strategizing. See you soon.